So let's see how the X and Y intercept can help us solve word problems. So for example, Christina is shopping for cupcakes and brownies for dessert. She only has $15 to spend. The graph below represents the equation. The equation is 2.50c plus 1.25b equals 15. And we have a graph here. The first question is, what does the y-intercept mean in the situation? So let's first find the y-intercept. Okay, so y-intercept's right here. So what does that tell us? So let's say that you're Christina. You are given $15 to buy stuff for a party for your homeroom. You're buying dessert, so your cupcakes and your brownies. Those are your choices. Now you want to make sure that as many people in your homeroom can get dessert, but it doesn't really matter if it's cupcake or brownie. You can go all cupcakes or all brownies, or get a combination of the both. We just want to make sure that everyone has one. So what is the best way to spend that $15? If you know that cupcakes is $2.50 a piece and the brownies $1.25 a piece, right? So if we know the linear equation and we graph it, we can actually, figure out something like that. Because let's forget the y-intercept for a minute. Let's say that on this line, after we have the equation and we graphed it, okay, so if we pick any point on this line, that actually tells us how many brownies and how many cupcakes that Christina can buy. So for example, if I look at this point, it's telling me that, okay, with the $15, so because this line represents, it's made from the situation where she has $15. So anything that's on the line is in budget. Okay, so let's say that we pick a point here. It's telling us that, okay, with the $15, she can buy 6 brownies and 3 cupcakes. So that gives us 9 items, right? Or she can go with a different point. Okay, she can buy 4 brownies and 4 cupcakes. That gives us 8 items. So you can see where I'm going with this, right? If you want to see which is the way that would give us the optimization of the money that we have, then we can go like that to find what combination can give us, more items. Okay. So anyway, that's a little bit of the topic here because we only want to focus on 2 extreme cases to see what that looks like. So the first one is on the y-intercept. So we can see that this point here, the y-intercept, is saying that she has 12 brownies, okay, because brownies on the y direction and 12 is on the right y direction. So we're saying that she buys 12 brownies on the y-intercept. And because this point here is 0, 12, that's saying that on this point, there's actually 0 on the x direction. So that means at this point, she's using all her money to buy only the 12 brownies, but no cupcakes. Okay, so that's what the y-intercept represents. Now, if we look at another question, if Christina buys only cupcakes, so only cupcakes means no brownies. Okay, then how many cupcakes can she buy? Well, we are then gonna take advantage of the graph. We're gonna look at, okay, at a point where there's no brownies, okay, so 0 brownies would be then 0 on the y direction, and we know that the x-intercept is where y equals 0, so we're looking at this point, y-intercept. So at this point, if she doesn't use any money to buy brownies, that means she's gonna have all her money to buy 6 cupcakes, because it's 6 on the x direction. Okay, so then if you were Christina looking at the situation, you would know that, okay, if I'm gonna spend all my money getting something, I might as well get all brownies because that gives me more items. It's just a better budget than all cupcakes.